Assalamu alaikum students. I hope you all are well. I am your teacher Sumayya Khan, and today we are going to start with the chapter Chemical Thermodynamics. This is your fourth chapter of the syllabus, and it is a simple chapter, though it is large, but the chapter is simple. So let's start the chapter now. Now let's first try to understand the meaning of the word chemical thermodynamics. We know the meaning of chemical, what are chemicals we know, and what is this thermodynamics. The literal meaning of the word thermodynamics means, thermo means heat and dynamics means motion or movement of heat. Okay, so thermodynamics can be literally defined as the study of motion of heat, but this definition is not fully describing what we are going to study in chemical thermodynamics. Okay, in this chapter we are going to study about the different forms of energy. All of us know that energy exists in various kind of different forms like solar energy, light energy, wind energy, kinetic energy, vibrational energy, potential energy, chemical energy, nuclear energy, and many more. And many of these forms are interconvertible under suitable condition. Not all the forms at any condition, but under some suitable condition some of the forms can be converted into the other. For example, we know that in hydropower plant what happens, the dynamic energy of that dynamo is converted to electrical energy. In nuclear power plant, the nuclear energy of an element is converted into what? Electrical energy. The electrical energy we use for lighting the bulb, for running the fan. So one form is getting converted to another. For example, in the engines we burn fuel. That fuel burns and produces heat, and that heat is then converted to mechanical energy. So we know that under suitable set of condition and suitable setup, one form of energy can be converted to another form of energy. In chemical thermodynamics will basically be interested in the energy changes that will be involved in a chemical reaction. Okay, our main focus would be a chemical reaction and what kind of energy changes are taking place when the chemical undergoes reaction, that we'll study in detail. It also talks about the quantitative relationship between the different forms of energy. It means how when this much amount of one energy disappears or utilized for producing the other kind of energy, how much energy will be produced. Okay, so one form is quantitatively related to another form. For example, we can say that when we burn the fuel like methane gas or the cooking gas, 1 kilogram of cooking gas will produce on burning suppose 1000 kilojoules of heat. Okay, so this is what a quantitative relationship between one form of energy to the other form of the energy. That we'll also discuss in this chapter. And what else we'll discuss? We'll discuss about how, this is the most important thing, how energy changes takes place in any physical or chemical process. What is process? Process is if whatever you are studying, if you say that is your system, if your system undergoes a change from one state to another state, or your system transforms from one condition to another condition, we will say a process has taken place. Now I am saying can be a physical process or a chemical process. Now what is physical process? When you observe the physical change in the state of the system. Now suppose you have a tray of ice and you are studying the tray of ice which melts into the liquid water. Now here what has happened? The solid ice has converted to liquid water. There is only change in the physical form of the water from solid to liquid, but there is no other chemical changes. It means the water remains H2O in both the case. Okay, so this is what a physical process has taken place. Okay, when we observe the chemical reaction, suppose you are doing the acid-base reaction, what happens? Acid and base, when they react with each other, they will produce salt and water. Now what has happened? Acid was liquid, and base was a liquid, and this product, which is salt and water, is also a liquid. So you will not observe the change in physical form of that particular system. But what you will observe, that the chemical composition of the system has changed. Before it was acid and base, but after the reaction what you will get? After the reaction you will get salt and water solution. Okay? So this is what a chemical process has taken place. And how the energy changes in this kind of chemical or physical processes, that we will study in thermodynamics. In simple words, in one line you can say that thermodynamics is the study of different forms of energies and its interaction with the matter. What I have said, I am repeating it. Thermodynamics is what? Thermodynamics is the study of different forms of energy and its interaction with matter. Now I can elaborate the definition and it can be more explanatory in this way. Thermodynamics is the study of science that deals with different forms of energy, quantitative relationship between different forms of energy, and the energy changes that occurs in different physical and chemical processes. So the definition includes three parts. It is the study of different forms of energy. Number two, quantitative relationship between different forms of energy. And number three is their energy changes that takes place in different physical and chemical processes. This is your chemical thermodynamics, okay? And the study of these will give you idea about these three things. Now, why we are doing the chemical thermodynamics? Why we are carrying out the thermodynamic study? What information we will acquire after doing the thermodynamic study? So let's see what are the scope of this chemical thermodynamics. Okay, these are the scopes of the thermodynamic study which I have mentioned on the board. The first one says it expresses the feasibility of a chemical reaction. Now, what is mean by feasibility of a chemical reaction? Suppose a chemist wants to carry out a reaction, he will not start doing the reaction actually in the laboratory with the actual chemicals by taking the risk of expenditure and other risk of explosion and all. He may do what? He may theoretically find out whether this reaction is possible under set of condition or not. Okay? So, whether the reaction can take place or can occur or not, that can be found out by studying the thermodynamics of that particular chemical reaction. So, this is one of the most important information which we will get from chemical thermodynamics. It expresses the feasibility of a chemical reaction, that is, whether the chemical reaction will take place or not under the given set of conditions. Second, if the reaction can occur, what is the extent to which that reaction will go for completion? Now, suppose if you are doing a reaction, you have found out that reaction, this A and B can react and can produce C, and C is very important to us, okay? But whether this A and B are reacting in large enough amount so that we are getting a suitable or desired amount of C or not. If the reaction is proceeding only 5% or 10%, that reaction will not be useful for us, okay? Because we will be wasting 90% or 95% of our reactant for obtaining that 5% or 10% of the product, okay? So the extent to which the reaction will proceed, that can also be determined with the help of thermodynamic study. So the extent to which the reaction will proceed will be determined by using the thermodynamic study. It means 50% reaction will proceed to 50%, 60% or 70%. That can be calculated with the help of thermodynamics, okay? And the last one is, if the reaction is possible to a good extent, we can also calculate the energy changes that will be involved in a chemical reaction, okay? The last point is what? We can calculate the energy changes in a chemical reaction or in any other physical process, okay? So these are the three important scope of chemical thermodynamics, and if you want you can pause the video and write these from the board. Okay. Now let's move forward. After the scope, let's discuss some limitations of the chemical thermodynamics. It means though it gives us these useful information, but it keep us deprived of some important informations. Okay, it means these are some drawbacks of this study. It means we are not going to get some important information from thermodynamics which are very important while carrying out any chemical reaction. So let's discuss the limitation of thermodynamics. These are the limitations of chemical thermodynamics. The three main limitations I have written on the board. Okay, let's discuss the first one. The thermodynamic study does not give any information about the rate of a chemical reaction or any physical process which we are studying. It means we will not get the idea that how fast or how much time will be taken for the completion of the reaction if that reaction is possible. For example, the reaction of this H2 and O2, oxygen and hydrogen, can produce water. Due to from thermodynamic study we come to know that the hydrogen and oxygen may react and form water molecule. And we know that this hydrogen and oxygens are present in atmosphere. So why these H2 and O2 are not converting into H2O? Because this reaction is very slow. Okay, it takes so many years for completion. Okay, under normal condition. So the kinetics of this reaction cannot be determined by the study of thermodynamics. Now this reaction is possible and can be made fast with the help of electric current or by other suitable condition. But under normal set of condition the reaction is very slow. Okay, so chemical thermodynamics does not give any information about the rate at which the reaction will proceed. Okay, the second important limitation of the thermodynamics is that the study is only restricted to the initial and the final stage of the system. It means suppose you are studying a chemical reaction, you will only study the reaction in the initial state when there was only reactant, and at the final stage, that is at the end of the formation of the product. Okay, now how the reactant is converting into the product, through which steps it is converting into the product, that is not discussed. Okay, so the path of reaction or what is happening between the path of the reaction cannot be discussed or is not studied in thermodynamics. Okay, so it is only concerned with the initial and final states of the system and does not give any information what is happening when the change is taking place. Okay, so how the reactant is getting converted to product, is there any formation of any other intermediate products in between, that information will not get. Okay, so in simple words you can also say that it does not give the mechanism of the reaction or does not speak about the mechanism of the reaction. So first one was it does not speak about the rate, second is it does not speak about the mechanism of the reaction. And where do we study these steps? We will study these two things in chemical kinetics, where we will study about the rate and the mechanism of a chemical reaction. Okay, in thermodynamics we are not able to get any information regarding this. Okay, the last one is we can only study macroscopic system. Macroscopic system. Okay, so macroscopic system means what? It means that when whatever you are taking for considering for a thermodynamic study, that particular system should consist of large number of entities. It means it should contain several millions of atoms, ions or molecules. You are not going to do the thermodynamic study on very small scale, what is happening in molecular level or what is happening in atomic level, that's we are not going to study in thermodynamics. So that system which we are considering for study should be a macroscopic system, not a microscopic system. Okay, these are the three limitations of your chemical thermodynamics. Okay, so till now we have studied what? We have tried and understood what is the meaning of chemical thermodynamics, what are the scope of chemical thermodynamics study, and what are the few important limitations of chemical thermodynamics. Okay, now let's move towards the basic concept of thermodynamics. Now what is the concept of thermodynamics? Okay, according to thermodynamic concept, the universe is divided into two parts. One part will be termed as system and the other part is termed as surrounding. Now let us understand what is system. System is very simple to understand. Whatever portion of universe you have selected for doing your thermodynamic study is your system. It can be a small system or a large system, but still a macroscopic system. Suppose you are doing a chemical reaction in a test tube or in a beaker and you are studying that chemical reaction, then that reaction mixture which is present in the beaker or the test tube will be your system. And anything else in the universe apart from that chemical mixture is surrounding. Okay, so it is very simple to understand. A portion of universe selected for doing the thermodynamic observation is known as system. So what is system? A portion of universe where the thermodynamic study is carried out is your system. I am just using the different words, but my different words are expressing the same meaning. A part of universe where the thermodynamic study is made is known as this thing, system. Now what is surrounding? Everything else outside the system is surrounding. Okay, so we know what is system, we know what is surrounding. Surrounding is the remaining entire part of the universe. Okay, but remember one thing, though we are defining surrounding as the everything else outside the system, but the system get affected only by its immediate surrounding. Okay, for example, suppose you have taken a reaction mixture in a beaker. So for that reaction mixture system, the immediate surrounding would be what? The outside atmosphere of that particular room where you are doing the reaction. What is the temperature, pressure or atmosphere of that particular room that will going to affect the system. What is happening in the Delhi, Calcutta or America? They are also surrounding, but it will not affect your reaction. What will affect your reaction? The immediate surrounding may affect your system. Okay, so though we are defining that surrounding is everything else outside the system, but remember one thing, keep it in your mind that the system get affected only by the immediate surrounding. Okay, and we are also concerned with the immediate surrounding only. Okay, now we know what is system, what is surrounding. Okay, I have given you the example of a reaction taking place in a beaker. Now that wall of the beaker that exists between your system and surrounding, these walls of the beaker are termed as boundary. Okay, boundary. So there is one more part you can define here. What is boundary? The boundary is anything which can be a rigid substance or which can be an imaginary line that separates the system and surrounding from each other. Okay, now let's say that it is not necessary that you are always studying the system in some container. Okay, in physical container. Look, beaker is a physical thing. It has walls, physical wall. Okay, it is not necessary that we are always studying the system which have the physical boundary to it. Suppose you are studying a atmosphere of some room. This is a room. Okay, now I am saying that I am going to study about the atmosphere of this room, including 1 square kilometer of this 1 square meter of this room. Okay, So 1 square meter of this room would be almost this much. There is no wall here in 1 square meter. Okay. So though the wall does not exist here, but my thermodynamic study will be restricted to only this much area. Okay. So it is not necessary that boundaries are always actual boundary. These boundary can be imaginary or virtual also. Okay. So what is boundary? How do we define boundary? Boundary is the line of separation between system and surrounding, and this boundary can be actual or can be imaginary. Okay. It is also important to understand the boundary. Okay. So boundary is what that separates the system from the surrounding, and this boundary is not necessarily a physical boundary, actual boundary. It can also be an imaginary boundary. Okay. So according to the concept of thermodynamics, the whole universe can be divided into system and surrounding. System is a portion of universe where the thermodynamic study is made, and everything else outside the system is your surrounding. The line of separation that separate the systems from the surrounding is known as boundary, which can be an actual boundary or a imaginary boundary. Okay, this is the basic concept of your thermodynamics. Now let us try to understand different types of possible system which we are going to study in thermodynamics. Okay. Now we will discuss types of system. The division of types of system is done on the basis of its capacity to exchange heat, that is energy, and matter with the surrounding. Okay. So this classification of system is done on the basis of ability of a system to exchange energy and matter with the surrounding. Okay. Now you can see I have given 3 types of system. First we will discuss open system. Okay. I have made a beaker here. Okay. Now in open system, the system is open to exchange the matter and to exchange the energy with the surrounding. Okay. So here both the exchanges are possible. That is, it can exchange matter with the surrounding and it can exchange energy with the surrounding. Okay. Now for example, suppose you have a hot cup of tea. When you place a hot cup of tea under the normal temperature, external atmosphere, what happens? You will find that the steam is coming out of that hot cup of tea, and after a while the tea will become cold. Now what is happening here? The matter is going from the system into the surrounding. Okay, and the heat is dissipated into the atmosphere and the temperature has lowered. Okay, so there is exchange of heat and exchange of matter also. Okay, so the system that can exchange energy as well as matter with the surrounding is your what? Open system. Okay, this is open system. For example, ourselves, human beings, we can exchange heat, we can exchange matter with the surrounding. Okay. Closed system. Now in closed system what happens? The system is completely closed, so the matter cannot go out or come inside the system. Okay. So here you will find that only the energy can be exchanged with the surrounding but not the matter. Okay. So the system that can exchange only energy but not the matter with the surrounding is your closed system. Okay. Now can we give the example of closed system? Any reaction mixture that is taking place in a closed container. Or take a cup of tea again. Take that cup of tea, hot cup of tea, and you just cover it with the lid. Okay. When we cover it with the lid, we are restricting the exchange of matter. It means no moisture can come into the system and the steam cannot go out of that cup of tea. Okay. So matter cannot be exchanged with the surrounding now. but heat can still dissipate into the surrounding from the wall of that cup. Okay, you will find that it is not like that once you cover the cup of that, it is not going to get cold with time. Okay, the rate of getting colder will decrease, but it is going to get cold after some time. Why it is getting cold? Because the heat can exchange from the wall of your system. Okay, so it still allows the exchange of energy, though restricted the exchange of matter. So what is closed system? The system that can only exchange energy but not the matter with the surrounding is closed system. Okay, now the last one is isolated system. Okay, in isolated system, the wall of the system is completely closed. Okay, and the wall of the system is covered with some insulating material. Okay, it means that it is thermally isolated from the surrounding. It will not allow the exchange of heat or energy with the surrounding. For example, thermos. When we take thermos, if you keep cold water in that thermos, it will remain cold. If you keep hot water or hot milk in it, it will remain hot. So energy is not able to exchange with the surrounding. Okay, so the system that cannot exchange energy or the matter with its surrounding is known as isolated system. What is that isolated system? The system that cannot exchange energy as well as matter with its surrounding is known as isolated system. For example, a chemical reaction that takes place in a thermally insulated container. Okay, it is completely closed and it is thermally insulated also, therefore both the exchanges are not possible. So when we carry out the thermodynamic study, we may come across any of this kind of system: open system, closed system, or isolated system. Okay, so these are the three important types of system. Now we will discuss the properties of the system. Look, when we take into consideration a thermodynamic macroscopic system for doing the thermodynamic study, we will select certain properties for describing the initial and final state of the system. Okay, now these properties of the system can be divided into two types, and this division is based on its dependence of property on the amount of matter present in the system. It means that some properties will be called as extensive property because these properties depends on the amount of matter which is present in the system, and some would be termed as intensive properties because these properties are independent of the amount of matter that is present in the system. Okay, so let's try to understand it in a better way. What are extensive property? Such properties which depends on whose value depends on the amount of matter that is present in the system is called as extensive property. For example, mass. If the amount of matter in the system is large or greater, the mass would be greater, and if it is lesser, the mass will be lesser. In the same way, volume. If the amount is more, volume will be more. If amount is less, volume will be less. Okay, so these are the two examples. There are several other examples like heat capacity of the system, internal energy of the system. Okay, all these things are what depends on the amount of matter that is present in the system. If amount get reduced, their values or their magnitude will also get reduced, and if the amount get increased, their magnitude will also get increased. Okay, so what are extensive property? The property of the system whose magnitudes depends on the amount of matter present in the system is known as extensive property. So it depends on amount of matter. Okay, can give the examples of mass, volume, etc. Okay. And what are intensive properties? Such properties whose magnitude is independent of the amount of matter present in the system. Okay. So it does not depend on, you can write, does not depend on amount. Okay. Examples are temperature, pressure, viscosity, density, boiling point, melting point. These are what? The intensive property. They do not depend on the amount of matter present in the system. For example, suppose I have a bucket full of water and I have asked you to remove that water in a glass and in a mug and in a bottle. Okay. Now you remove that into different containers and find out what is the temperature of all the containers, water in all the containers. You will find that the temperature of the water in all those containers are same. Whether it is 1 liter, 2 liter or 50 liter, the temperature remains same. In the same way, if I ask you to find out the boiling point of water, you can take 100 ml of water, 1 liter or 200 liter of water. The boiling point of water is going to come as 100 degrees Celsius only. Okay. So boiling point is not depending on the amount of matter. It is independent. In the same way, density. The density of water I am saying. It is, I think it is 1 gram per cm cube. So if you take 1 ml of water or 1 liter of water or 1000 liter of water, the density of the water will remain same. In the same way, all these properties which do not depend on the amount of matter present in the system will be termed as what? Intensive properties. Okay. So intensive properties examples are boiling point, melting point, temperature, pressure, viscosity, density, etc. Another important point you should remember here is extensive properties are additive in nature. Okay. These properties are additive and intensive properties are non-additive. Okay. Now what is meant by additive and non-additive properties? Additive means what? Which can be added. For example, suppose you have a system made up of two different components. The mass of one component is X and the mass of other component is Y. Now what would be the total mass of the system? It would be X plus Y. So how we have obtained that total mass? By adding the two parts of the system. Okay. So extensive properties are additive in nature. They can be added, but intensive properties are non-additive. Okay. You cannot say that for 1 ml the boiling point is 100 degrees Celsius and for the remaining 99 ml it is 100. So the total boiling point is what? 200. No. You cannot add the intensive properties. Intensive properties are non-additive. Okay. And extensive properties are additive. One more important interesting point about intensive properties is that these intensive properties are sometimes the ratio of two extensive properties. Okay. Intensive properties are the ratio of two extensive properties. For example, let's take density. Density is what? An intensive property, but density, we know the formula of density is what? Is equal to mass upon volume. Mass is an extensive property, volume is an extensive property, and the ratio of these two is an intensive property. Okay. So remember, intensive properties are the ratio of two extensive properties. Okay. I hope you have understood what are extensive and what are intensive property. You should be able to identify the properties whether they are extensive or intensive. It is not like that you will memorize these. Okay. For example, suppose I am saying molar concentration of a solution. Now you try to find out whether molar concentration is an extensive property or intensive property. Okay, this is your homework. Molar concentration is extensive property or intensive property. Okay. Now here we have completed the properties of the system. Now let's move forward to another important term, that is state of the system. Okay. I have repeated many times that the thermodynamic study only talks about or takes into consideration the initial and final state of the system. Okay. Now what is mean by state of a system? How do we describe the state of a system or state of anything? To describe the state of anything, we use the certain properties. For example, suppose you want to buy a house. When we want to buy a house, you will ask that in which area the house is located, what is the structure of the building is of how much story, how many rooms are there in that particular flat, and so many questions you are going to ask to find out the state of that house. Okay. In the same way, suppose you want to buy a car and you have asked your friend to or a bike, and you have asked your friend to tell you about some good bike. So if he is telling you that I have seen for you a very good car and you should buy it, so are you going to buy it like that? Are you not going to ask some questions? So you may ask that what is the model, on which year it was given, and what is the color of the car, for how much kilometer it has run. Okay, there are many questions which you may ask regarding that car, which will tell you about the state of that car. Okay, so state of the system is what? Is the set of the properties that are used to describe the condition of the system. Okay, so in case of thermodynamics, you may take several properties like temperature, pressure, volume, mass, number of moles. These are the set of properties. If you describe these properties, you will be able to understand what is the state of the system. Okay, so state of a system is what? A set of variables or thermodynamic properties that describes the condition of the system is known as the state of the system. Now these variables which we use to describe the system can be termed as, some of them can be termed as state function. Now let's see what is state function. State functions are the properties of the system whose magnitude only depends on the current state of the system and is independent of the path followed to reach that state. It means that these are nothing but what? State variable or the thermodynamic properties which we use to describe the state of the system. Okay, like temperature, pressure, volume, what? These are what? State variables or the thermodynamic properties which we use for describing the state of the system. Now these state variables are also termed as state function. Why they are called as state function? Because their value does not depend on how the system has acquired or has moved from one state to another state. It is independent of the path followed by the system to reach any particular stage, and it depends only on the current state of the system. For example, there is a system, a gaseous system, whose in state 1, in initial state 1, the thermodynamic property of this system was found to be P1, the pressure was P1, volume was V1 and temperature was T1. Now suppose you are studying, the system has gone under some process and it has changed from state 1 to state 2. Now in this state 2, the pressure, volume and temperature have acquired some new value P2, V2 and T2. Okay. Now why I am saying this P1, V1 and T1 and P2, V2 and T2 are state function? Because it depends only on the current state of the system. Now you will say that initially the pressure was 1 atmosphere, the volume was 10 centimeter cube and the temperature was 25 degrees Celsius. Okay. Now the system has gone through some changes and has come to state 2. Now suppose the temperature hypothetically has changed to 2 atmosphere. The volume has become 5 cm cube and the temperature is now suppose 40 degrees Celsius. Okay. You will say that in state 1 the value of these state function are this, this and this, and state 2 the values are this, this and this. You are not going to state how this change has taken place, how the pressure has gone from 1 atmosphere to 2 atmosphere, how the volume has decreased from 10 centimeter cube to 5 centimeter cube. That is not what we are concerned. Okay, and this is, and their value also does not depend on how the change is taking place. Okay, suppose your mother asks you how much water is there now left in the tank. You will just say that, mother, the tank is half full, quarter full or completely empty. You are not going to describe that because we have opened the tap, now the water is gone here and there and the water has come from pipe to our tank like that. We are not going to describe how that change has taken place. You can describe the volume of the water in the tank just by saying that the tank is half full or fully empty or fully full. Okay, so these value depends only on the current state, and how the change has taken place does not affect the value of these properties. Okay, so such properties of the system whose magnitude depends only on the current state of the system but are independent of the path followed to reach that state are known as state function. And what are state function? For example, temperature, volume, pressure, these are all what? State function of the system. Okay. Another kind of functions are also there which are known as path function. What are path function? The properties, these are not properties actually, the quantities of the system that depends on the path of the followed by that property to reach the particular state is known as path function. Path function depends upon the path and does not depend on the current state. For example, work. Work is a path function. Now suppose I am telling you to come to college from your home. Okay. Now for coming to college, you may take a ride. You can take a rickshaw ride. You can walk to the college, and you can walk to the college from some shortcut or from some long cut. So your journey from your home to college will depend upon the ride which you are going to take. It depends upon the mode which you are going to select for your transfer. Okay, so the amount of work will depend on which mode you are selecting for moving from one place to another place. The distance between the two things, your college and your home, remains same, but the work you will perform for covering that distance may vary. If you are going by rickshaw, you are doing very less work, you are not doing any work, you are just coming into rickshaw, sitting into the rickshaw and dropping at the college. If you are riding the bike, if you are driving the bike yourself, you are doing some work. If you are walking by some shortcut, you will reach the college earlier. If you take the long cut, you have to do more work. Okay, so the amount of work done to reach the college will depend on the path you have selected to do that work. Okay, though the distance between the 2 points remains same. Okay, but the amount of work will differ due to the path used for reaching that particular state. Okay, so work is what? A path function, it is not a state function. Similarly, heat is also a path function, not a state function. So today we have studied what? Today we have studied about the state function and path function. State function depends on current state, path function depends on the path which is used for reaching that particular state of the system. Okay, so let's finish our lecture today only here. In next lecture we'll proceed with the further part of the chapter. Okay. Until then, please be safe. Take care of yourself. Allah.